Good morning, everyone. This is Mr. Chalman here. We're going to be going over the Lesson 9 practice problems. Okay, so we're going to start on number 2 here. So let's take a look. All right, it looks like we have two functions here, A of t and M of t, and these are talking about the average temperatures in Minneapolis and Aspen. So A of t is the temperature in Aspen, and M of t is the temperature in Minneapolis. The input is T in months. So we're going to input months, and that's going to give us a temperature, right? So the question is, oh, this light's really bright. Question is, which function had a higher average rate of change between the beginning of January and the middle of March? What does this mean about the temperature in the two cities, right? So first, we need to take a look at these months. These months are the months of the year, right? So January is month number 1. Oops. Which is right here in between the 1 and the 2. And March is month number 3, which is right here. Okay, so let's go up and make some points. That way we can draw our line. All right, now already looking at this, it looks like these two dots are further apart. Oh, you can't really see that well. There you go. These two dots right here are further apart than these two dots. So it looks like this red one is going to be going up faster than this blue one, but we can always draw our line to check that out. So I'm just grabbing any kind of straight edge. I just use like a pen or pencil or marker, or if you have a ruler, that's great. And just go ahead and connect those two dots and make a line that keeps going. Okay, we'll do the same thing with the blue one. Okay, so you can clearly see that this one is going up faster. So we can say the average rate of change is higher in Minneapolis than it is in Aspen, Colorado, in between these 2 months, right? So it's higher in Minneapolis. So M of T, which is the average or the rate of change of temperature, right? Is higher let me reword that. The average rate of change is higher between or for M of T between January and March. And this means that temperature was going up faster, right? Was rising faster, or it was getting warmer faster than it was in Aspen. Sorry for my chicken scratch. Or A of T. It's always fun to use the math notation. Okay, that's problem number 2. Let's go ahead and move on to problem number 3, which is on the next page. Okay, so looking at this one, it's totally different. Here are two graphs representing functions f and g, and we're going to select all these statements that are true. Now, f is this black one, and g is this green one, going up like that. Okay, so this says f of 0 is greater than g of 0. Now, remember, these are inputs, right? So we're going to go to those numbers, which are right here, and we're going to go up and see how high they are. We want to see which one is higher at 0. So f of 0 is down here, and g of 0 is down here. Now remember, the alligator always eats the bigger side, right? So this is saying that f of 0 is higher than g of 0, which is not the case. At 0, f is down here, and at 0, g is way up here. So this one is not true. There are two values of x where f of x equals g of x. That means where they intersect, right? Where the two lines cross. Okay, so they cross here and they cross here. And this would be true. There are two values of x where they do indeed cross. It's at negative 2.1 or something like that, and about 3.1, somewhere in there. So we're going to circle this one. Okay, f of negative 1 is less than g of negative 1. So we're going to go to negative 1, and they're saying this one is smaller than this one, which is right here, and this one is right here. So that's definitely true. The green one is definitely higher than the black one, or the black one is lower than the green one, right? Okay, so we're going to do the same thing for this one. F of negative 3, this says f of negative 3 is bigger, right? Is bigger than g of 4. So let's go to negative 3 and see where f is. F is right here. So this is how high it is. Now we want to see if at 4 is g going to be higher than this point, which looks to be about 8 or 9. Let's find out. 4, g is right here, which looks to be about 6. So this one is also true. F is higher. Okay. Don't forget your greater than less than symbols. They're just alligators. They always eat the bigger one. All right. Number 4. The three graphs represent the process of 3 runners in a 400-meter race. Okay, so this is the finish line. Right, there's the finish. The solid line represents runner A. So runner A looks like they ran up here, took a break, and then sped up again. The dotted line represents runner B. So the dotted line is this one in the middle, and they slowed down. And then the dash line represents runner C. So that's the bottom one. Okay, notice 400, that's the finish line, is up here. So this is like the finish line, right? The finish line. I like to label these things. That way, it's easier for me to like determine what's happening in the graph, right? So one runner ran at a constant rate throughout the race. Which one was it? Now, constant rate means straight line, right? Like there's no curves or anything like that, or it doesn't like change direction or anything like that. And it looks like that's the bottom one, runner C. The second runner stopped running for a while. Oh, a second runner stopped running for a while. Which one and during which interval of time did that happen? Now, the interval of time, that's this down here, right? So they want to know which runner stopped running and how long, or in between which times did they do that. This runner was going up and then stopped right here, and then for quite a few seconds they didn't move, and then they kept running, right? Looked like they were taking a break. So that happened right here. If you go down, looks to be about 15 seconds, about, we don't know exactly, so you can take a guess here. But remember, it's in between 10 and 20. Looks like it's right between the middle, so that's 15. And it looks like right about here, they started running again. And that looks to be about 44, maybe 43. I don't know. If you said 45, I guess I could give you that too, but it's in between 40 and 50. Okay, so I would say, and that was runner A. So runner A, and between 15 and 44 seconds they rested. Okay. Describe the third runner's race. Be as specific as possible. The third runner. So that is runner C. Runner C ran at a constant rate the whole time, right? So pretty easy to explain that. However, let's talk about where they were in comparison with the other runners. So it looks like they started off going slower than everybody else, and they stayed at that same speed, and eventually they passed runner A, and then they passed runner B right before the finish. Okay, so uh, runner C ran or began at a slower pace, or we could say ran at the same speed the whole race. Ran at a constant speed the whole race. Um, Starting out slower than the other two. Then eventually passing both of them. Before winning the race. It's important to note that too, that they won, right? Oh, here it is right here. Who won the race? Runner C. How do we know it was runner C? Because if you look at the graph, they got here in about 39 seconds. Runner B got there in about 40, I don't know, 47 seconds. And runner A got there in about 50, 54, 53. Either way, all three of these times are fantastic mile times. This one obviously is amazing. Okay, runner C finished the race in 39 seconds, which means they got to the top first. They got to 400 meters first. Okay, that's pretty much the gist of this one. If you have any questions, please let your teacher know. Wow, why did this turn upside down all of a sudden? That's weird. Should look like this.